About model evolution matrix. So today we are going to study about these factors which determine the performance matrix, evolution matrix for a machine learning model. So let us start with confusion matrix. So before that, what we are going to do is, let us take a sample of blood, you can say, we have different samples and we need to determine whether that patient is positive or negative for a particular disease. It can be malaria, or it can be COVID, or it can be any other disease as well. So for now we are taking, suppose, malaria patients. So we have some sample here of positive and negative sample reports. So this person is negative, positive malaria, and so like this we have a sample. Suppose we take positive as 1 and negative as 0. So suppose we have predictive data set and as X and actual results as Y. So let us see, suppose we predict 0 and we are predicting a negative and it is coming as 1. We are predicting a positive and it is appearing as 0. Predicting as 1, it is coming as 1. We are predicting as 0, it is predicting as 0, coming it is 0 in actual. So we have around 5 to 10 data sets here. So we have around 7 patient data sets. So now let us draw the confusion matrix and see how this will happen. So now, before about model evolution matrix, let us start with confusion matrix. What this represents the predictive positive and negative and actual predictive and positive. So suppose we have 4 terms here. One is true positive, false positive, true negative, and false negative. So when we have predictive positive results in actual positive, then it is true positive. When negative predictive results in actual positive, then it is false negative. And when predictive positive results in negative actual result, then it will be false positive. And when actual negative results in predictive negative results in actual negative, then it is true negative. Now there are 4 factors which we use to determine the matrix: accuracy, precision, recall, and F1 score. So now let us start with accuracy. Now let us talk about accuracy. So accuracy is nothing but all results which were correct, that means positive resulted in positive actual and negative predictive resulted in negative actual. So that means TP plus TN divided by TP plus FP plus FN plus TN. So now let us calculate this in the previous data set. So here, what is this? Let us start with the data set to calculate the accuracy. So what is this? This is nothing but false negative, this is nothing but false positive, this is true positive, this is true negative, this is false negative, false positive, this is false negative, and this is true positive. So how many are let us put, like, we have 2 true positive samples, we have 2 as false positive, and similarly false negative also true. and 2 negative we have 1. So now let us use it in our equation. So when we talk about Tp plus Tn, so we have, so what this means? This means this comes out to around approx 42%, or you can say approx 43%. This is the accuracy. So this is how it determines the, model matrix, whether this model is suitable or not, using accuracy. Now next one is precision. So precision is calculated as Tp divided by Tp plus Fp. That means it's a measure of true positives divided by the predicted positives. So what does this mean? That how our model is performing with respect to the prediction. So, and this is used in case of, suppose we are using spam filters. This has great use to, because what we are looking for, we want to reduce Fp to increase Tp here. So what does this mean? Fp is false positive, Now let us talk about recall. What is recall? Recall is Tp divided by Tp plus Fn. So that means true positive divided by actual positive outcomes. So we use this in to get the accurate results, to get better results for disease detection. Like suppose we are, for cancer, what we want to do, we want to reduce Fn here. What does this mean? Fn is a parameter, that means that actually cancer is there, but it is not predictive positive. So that's a big blunder. Now let us talk about the next factor, F1 score. What does this mean? It's calculated as 2 into recall into precision. Now let us talk about sensitivity. Now sensitivity is same as recall, which is also called as true positive rate. Now there is another term called specificity. This is called as, this is Tn by Tn plus Fp versus this determine true negative rate. Now when we talk about false positive rate, there is a term called false positive rate, which is nothing but 1 minus specificity. So we have now two terms is true positive rate and false positive rate, which are reverse of each other. Now let us talk about a ROC curve. So ROC represents receive operating characteristics. What does it represent? It represents the performance of classification algorithm. At different thresholds. Let us see the curve. So basically there are two parameters which is uses, that is true positive rate, CPR, which is on the y-axis. And the left axis uses false positive rate. And when we see the curve online, you can see this goes something like this. And area inside this curve is called AUC, which determines at which threshold this area is maximum. That will be the buffer model. So at this threshold, area will be maximum. Area will be more than this curve. Now let us. Hello friends, so today we have covered day 13 of our exciting AI journey. So today we have covered model evolution metrics, which are accuracy, recall, precision and F1 score. I hope you have understood it. If you have any doubts, just put in comments. And also, you can mail it to aicodegear@gmail.com. Now, next we'll be covering how to make the ML model in Python just in 10 minutes. So, next will be making a ML model from scratch. So, please do join to our channel, do subscribe to our channel, do hit the like button and also press the bell icon so that you don't miss any day of the AI content challenge. Thank you and bye bye.